Hello, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It's Tuesday, the 7th of July, 2026, and we've got a properly eclectic mix for you today.
We're starting close to home, very close to home, with a beach in Queensland and some rather mysterious silver balls.
Then it's out to an asteroid, out to an interstellar comet, out to a planet 40,000 light years away, out to a merger of 6 galaxies 12 billion years in the past, and finally, right out to the edge of the solar system itself.
A proper grand tour. Let's get into it. And let's start with a story that reads more like a mystery novel than a science bulletin. Over the weekend, 6 large metallic spheres washed up on Forest Beach near Townsville in North Queensland.
And naturally, the internet had some theories. But the real explanation is almost as interesting. The Queensland Fire Department cordoned off a 50-meter exclusion zone, and crews in hazmat gear carefully secured the objects into drums.
Because these things can be genuinely hazardous. Space archaeologist Associate Professor Alice Gorman from Flinders University had a look at the footage and said they're consistent with pressurized fuel vessels, likely made of titanium alloys. And titanium has an extremely high melting point, which is exactly why these survive re-entry when so much else burns up.
They're sometimes nicknamed spaceballs, and Gorman notes that they can show up years after the launch that produced them. There was no scorching on these ones, which suggests it came from a rocket stage that fell away early rather than from a spacecraft that burned up on final re-entry.
On Sunday night, the Australian Space Agency confirmed it's working with Queensland authorities and the National Emergency Management Agency and said in a statement that the objects are, quote, consistent with debris from a foreign rocket body that recently re-entered the atmosphere from orbit.
They haven't officially named a launch yet, but there are a couple of candidates worth watching. China launched the Long March 6 and the Long March 8A over that same weekend. Nothing confirmed, but the timing lines up.
It's a great reminder of just how much hardware is coming back down to Earth these days. More launches than ever means more re-entries than ever. And Australia's coastline, being enormous and facing a lot of open ocean, catches more than its fair share.
If you're on the Queensland coast and you spot something like this, please don't touch it. Call it in. These vessels can still contain leftover propellant, like hydrazine, which is nasty stuff.
Great advice. We'll keep an eye on this one and let you know if the source gets confirmed. From debris coming down to a spacecraft going up close and personal with an asteroid 62 million miles away.
This is JAXA's Hayabusa 2, the same probe that brought samples of asteroid Ryugu back to Australia's own Woomera Desert in 2020. It's been out on an extended mission ever since, and on Sunday, it completed its first asteroid encounter of that extended mission, a flyby of asteroid Torifune.
And Flyby undersells it a bit. Hayabusa 2 came within about 800 meters of Torifune, traveling at something like 18,000 kilometers an hour. JAXA has described it as a deliberately risky operation designed specifically to test high-speed, high-precision navigation, technology that could one day deflect a hazardous asteroid.
Torifune is a 2-lobed object, a bit like a peanut or a snowman, about 450 meters across, spinning once every 5 hours. The pictures that have come back, taken by the optical navigation camera and the thermal infrared imager, show rocks and boulders scattered across both lobes. Yuya Mimasu, who heads the Hayabusa 2 extended mission team, told a press conference he was genuinely shocked by how good the image was, given it was captured in a fleeting moment during a high-speed pass. The infrared images are just as valuable. They reveal cooler shadowed regions and warmer sunlit patches, which tells scientists about the surface texture and thermal behavior of the rock.
Hayabusa 2's next stop is even more ambitious, asteroid 1998 KY26, just 11 meters across, potentially the smallest asteroid ever visited by a spacecraft. That encounter isn't due until 2031, so Torifune was very much the warm-up act.
A warm-up act 62 million miles from home. Not bad for a spacecraft that's been flying for almost 12 years.
Sticking with old travelers, let's check in on 3I Atlas, the interstellar comet that's been fascinating astronomers since last July.
New research out this week, led by Cyrielle Oppitum at the University of Edinburgh, used the European Southern Observatory's Very Large Telescope to study the comet's chemical fingerprint in detail. And it's given us our best clue yet about where 3I Atlas actually came from.
The short version? This comet almost certainly formed in the outer reaches of a star system built around a star far older than our Sun. Combined with earlier work on hydrogen and carbon isotopes, some estimates now put the comet's age at somewhere between 3 and 12 billion years, which, if it holds up, would make 3I Atlas one of the oldest objects ever directly studied by humanity.
Oppitum put it beautifully. She said interstellar comets are basically fossils from planetary formation, but from a system very far away that we're lucky enough to study up close for once.
3I Atlas is only the third confirmed interstellar object, after Oumuamua in 2017 and Borisov in 2019, and it's already fading as it heads back out of the solar system for good. The VLT team says these observations are nearing their end simply because the comet is getting too faint to study.
Which makes the timing of this result rather poignant, one of our last really detailed looks at 3I Atlas, and it turns out to be one of the most revealing. And with the Vera Rubin Observatory now fully operational, scientists reckon we could be entering what they're calling the golden age of interstellar object discovery.
Every new one a fresh surprise by the sound of it.
Now for a discovery that even NASA didn't think was possible when this spacecraft launched.
This is TESS, the Transiting Exoplanet Survey Satellite. Since 2018, its entire job has been watching for the tiny dimming of starlight when a planet crosses in front of its star. That's given us hundreds of confirmed worlds. But this week, in a paper in the astrophysical journal Letters, a team reports that TESS has found a planet using a completely different method, gravitational microlensing.
Microlensing relies on general relativity. When one star passes almost exactly in front of a more distant background star, its gravity bends and briefly magnifies that background star's light. If the foreground star has a planet, that planet leaves its own tiny ripple in the brightening.
The planet in question is called Gaia 23 Bra b, first hinted at back in 2023 by the European Space Agency's Gaia mission, which spotted the stellar brightening but didn't have enough data to confirm a planet. TESS's archived observations from that same event turned out to hold the missing piece.
It's a super-Jupiter, about 1.6 times Jupiter's mass, orbiting an orange dwarf star some 40,000 light-years away, vastly further than the planets TESS usually finds within about 150 light-years.
University of New Mexico's Diana Dragomir, who worked on the discovery, said plainly that nobody expected TESS to ever be capable of finding this kind of planet. And because microlensing events are one-offs, they happen once and never repeat, this really was a needle hiding in 8 years of haystack data.
But team member Mallory Harris had a great line about it. She said microlensing will probably find the first Earth analog, and then we'll just have to wave at it as it drifts by, because we'll never see it again.
Bittersweet, but also a lovely preview of what NASA's upcoming Nancy Grace Roman Space Telescope will do at scale. It's expected to find around 1,000 planets this way, from one planet 40,000 light-years away to something on a truly different scale altogether.
A new paper led by Z.L. Wen of the Chinese Academy of Sciences describes what astronomers are calling an extremely rare galaxy megamerger. 6 massive galaxies caught in the act of merging into one, roughly 12 billion years ago.
Using the Mayold, Boak, and Blanco telescopes, combined with earlier James Webb and radio interferometry data, the team reconstructed what was originally thought to be a single distant galaxy hosting an active black hole. Instead, it turned out to be a protocluster, a gravitationally bound clump of galaxies in the very earliest stage of building what's called a brightest cluster galaxy.
None of these 6 are lightweights either. 4 are already individually massive, and together they're packing hundreds of billions of solar masses of stars into a region smaller than the Milky Way. Their combined star formation rate is somewhere between 70 and 160 solar masses a year. Compare that to the Milky Way's current rate of fewer than 10.
Based on how fast the galaxies are moving relative to each other, the team estimates the whole merger will wrap up within a few billion years, producing one enormous, ultra-luminous galaxy at the heart of a young cluster.
It's also a nice test case for the relationship between black holes and their host galaxies. The young central black hole in this system is growing right alongside its 6 merging hosts, which should help refine our models of how that black hole to galaxy relationship actually gets built in the early universe.
12 billion years ago, and we're only piecing it together now. Astronomy really does run on a different clock.
And to finish, let's go all the way out to the true edge of the solar system, courtesy of NASA's New Horizons spacecraft.
New Horizons is currently about 66 astronomical units from the Sun, more than 66 times the Earth-Sun distance, and it's still carrying a working instrument called SWAP, the Solar Wind Around Pluto Detector. A new study led by Dr. Heather Elliott at the Southwest Research Institute has used SWAP to track exactly how the solar wind slows down as it heads toward interstellar space.
The solar wind starts out supersonic, around 1,000,000 miles an hour. But as it travels outward, it runs into incoming neutral gas drifting in from interstellar space. That gas gets ionized, gets picked up by the solar wind, and effectively acts as a drag, slowing the whole flow down.
Elliott's team found the slowdown steepens the further out you go. By around 58 astronomical units, the wind is measured at somewhere between 13 and 15% slower than it is near Earth. Earlier data, between 30 and 43 AU, had only shown a 5 to 10% dip. So this confirms the drag really compounds with distance.
Why does this matter beyond pure curiosity? Because the shape and strength of this boundary, the heliosphere, controls how many galactic cosmic rays make it through to threaten astronauts on long missions to the Moon or Mars. Better maps of the boundary mean better radiation forecasts for future crews.
New Horizons is expected to reach the actual termination shock, where the wind drops below the local speed of sound somewhere between 2029 and 2040, depending on how the models settle. It would only be the 3rd spacecraft in history to make that crossing, after Voyager 1 and Voyager 2.
Dr. Alan Stern, the mission's principal investigator, put it nicely. New Horizons remains the only active spacecraft out there in the outer heliosphere, quietly building on everything the Voyagers found decades ago.
A fitting note to end on, from a beach in Queensland to the true edge of the sun's influence.
That's a wrap on today's edition of Astronomy Daily. Beach mysteries, asteroid close calls, ancient comets, hidden exoplanets, a 12-billion-year-old mega merger, and the edge of the solar system itself.
If you enjoyed today's episode, please hit subscribe wherever you're listening and leave us a review. It genuinely helps new listeners find the show.
And here's today's Did You Know for you. Hayabusa 2's flyby of Torifune happened at a distance of under a kilometer at 18,000 kilometers an hour. That's roughly the same speed the International Space Station orbits the Earth.
I'm Anna.
And I'm Avery. We'll see you next time on Astronomy Daily.